Hello everyone, my name is Akinsola Ahmed. I'm a graduate student of computer science at Austin Peay State University in the United States of America. I'm here to present my research paper, Enhancing Software Supply Chain Resilience, a strategy for mitigating software supply chain security risks and ensuring security continuity in software development lifecycle. Let's move on to the abstract of the paper. This paper explored a strategic approach and the preventive measures that are needed to safeguard the software supply chain against evolving trade. It aims to foster an understanding of the challenges and the vulnerability inherent in software supply chain resilience and to promote transparency and trust in digital infrastructure that underpins our contemporary society. And we are going to do so by examining the software supply chain resilience concepts and assessing the current state of supply chain security. And we are going to provide a foundation for discussing strategies and practices that can mitigate security risks and ensure security continuity to the software development lifecycle. So let's move on to our introduction. Importance of software supply chain in the digital transformation. In an era dominated by digital transformation, the software supply chain is essential to creating and implementing programs that run a networked world. And some of the components that makes up the software supply chain include the developer's code, the configuration, the deployment configurations, different libraries used in the systems development, and the plugin and open source, and then the proprietary binaries and container dependencies in the systems development. When I make system, I'm talking about application here. I'm talking about it encompasses applications, software applications, it encompasses systems, different systems. This connectivity leaves the software supply chain open to a wide range of security threats, from deliberate assault to unintentional weaknesses. And vulnerability in the software supply chain can lead to backdoor access. It can lead to malicious software installation. It can lead to application downtime, and it can even lead to data leakage, such as personal identifiable information of users. That is the PII, which means that the increasing software supply chain resilience is critical as most organizations now depend increasingly on open source libraries, integration of third-party components, and different collaborative development methods. So let's move on to understand the software supply chain resilience. So this diagram depicts the various ways the software supply chain could be poisoned or abused. We have the source integrity and the build integrity. And we can see from the source integrity, we can see a situation whereby a developer submits a bad code and a malicious code submitted, or a flawed or harmful code in the system could result to a foothold for the cyber attacker to get foothold and perform their insidious acts. And we can also be under the source integrity, we see the Git also, that is the source control, and which means that an attacker can gain access to the source control system, which allow them to modify or inject malicious code. We have seen that happen in various software supply chain attacks that have happened in the previous times. We are going to analyze that going forward also. And on the build integrity phase, we see the continuous integration and continuous deployment, which means that if the build process, including the dependencies, is flawed, an attacker can introduce malicious dependencies, that compromise the build integrity. And an attacker may gain access to the continuous integration and the continuous development deployment platform, allowing them to alter the build process or introduce malicious code. And under the distribution, an attacker can also compromise the package repository, which is here, which enable them to distribute malicious packages to users. And users may unknowingly download and even use the compromised package, which would lead to potential security breaches. So let's move on to the next slide. Understanding the software supply chain. So we're going to define the software supply chain now. The software supply chain, what is the software supply chain? We can say anything that interacts with an application or a system contributes to and contribute to the development throughout the software development lifecycle is considered a part of the software supply chain. And the software supply chain encompasses different phases. We have the requirements phase, we have the defining and the designing phase, we have the coding phase, we have the testing phase, and we have the deployment phase. And even the deployment, we have another phase which is called the maintenance phase. And it is at this phase that the different code base is being maintained and managed for updates. So from a consumer-oriented perspective, is software supply chain consists of all the components required to produce a software product, including the software developers, the open source library used, the bespoke code of the developer, and different DevOps technologies that are used. So this is a diagram of the open source request trend. You can see that from the year 2018 to the year 2023, there has been an upward tick in open source requests. And this uptick has also resulted in malicious packages being discovered, which has twice that of the year 2018 and the previous years even in combined. So let's talk about the incidence of software supply chain attack and their impacts. The first one I have on my slide here is the MoveIt breach. So MoveIt is a managed file transfer software developed by Progress Software. This software is designed to securely exchange critical information, and its widespread adoption across various sectors, including healthcare, finances, and government power start and make it a critical node in the digital supply chain of many organizations. The software role as a secure conduit for sensitive data transaction places it at the heart of organization operation where integrity and confidentiality are paramount. So it happens in the year May of 2022. There was a disclose that a movie has been compromised, and this compromise was not merely an isolated incident, but a part of a larger coordinated supply chain attack, which was aimed at infiltrating the network of organizations that uses MOVIT for secure data transfer. And the attacker exploited the vulnerability within MOVIT software in order to gain unauthorized access, thereby exfiltrating sensitive data being processed through the system. And the breach of MOVIT software had a pronounced ripple effect, which impacted a wide range of organizations that depended on the software for secure data exchange. So moving on to the next incident of software supply chain attack, we have the Microsoft Exchange server. In the same manner as the MOVIT in the early of 2021, the cybersecurity world was also worked by disclosure of the significant vulnerability within the Microsoft Exchange server. This vulnerability provided threat actors a gateway to infiltrate email servers globally before they are patched. This affected a wide range of organizations worldwide, which leveraged on the vulnerability. The threat actor were able to establish a foothold by creating a web shell, which is a tool that enabled them to remotely control the compromised server. And this control allowed them to exfiltrate data, which included emails and all that sensitive data, like their account information. And they were even able to maintain persistence by deploying a malicious software into this compromised system of these organizations. The incidents not only underscored the indispensable need for timely software patching and supply chain security, but also cast a spotlight on the intricate challenges of protecting enterprise systems. Another incident we are going to look at is the colonial pipeline. Also in May of 2021, the cyber group known as DarkSide got a foothold into the colonial pipeline through an exposed password for a VPN account. And this account was obtained from a prior data breach on a different platform. The ransomware attack of Colonial Pipeline, and Colonial Pipeline is a major US fuel pipeline operator. This marked a significant escalation in the cyber threat landscape, particularly against critical infrastructure, because Colonial Pipeline supplies 45% of East Coast fuel, which includes gasoline, diesel, and jet fuel. And this breach caused a forced the halt in operation during the cyber attack for different businesses and even homes. The next cyber incident we are going to look at is the solar wind breach. SolarWind is a key player in the service management industry, and they were also targeted in a similar supply chain attack. Like every other supply chain attack, rather than attempting to infiltrate an organization network directly, a supply chain attack targeted a third party with access to its system. The third party in this instance was the SolarWind Orion platform, and the software platform had a loophole that allowed the attacker to gain entry and spoof the target organization users and accounts. The threat actor were able to inject malware into the Orion system of the updates, which had the potential of reading system data and blending seamlessly with regular SolarWind operation, which makes it undetectable by even standard antivirus software. The fallout from this attack was very significant and it affected 18,000 SolarWind customers. They installed this update that was pushed by the update by the Orion server, and this update contained malicious software. And this breach allowed attackers to access customer information and even conduct espionage activities against various organizations. So now let's look at the different strategies to mitigate this kind of cybersecurity attack. The number one I have here is the secure development practices. The term secure development describes the collection of methods, procedures, and instruments developed to find and fix security vulnerabilities in software system early on. And at this stage, that is the most economical stage to fix a vulnerability in a system before it is deployed to various users. This practice provides a proactive defense against coding mistakes and security flaws by thoroughly inspecting the software code at different development lifecycle phases. For example, in code review, a seasoned professional carefully evaluates the code base for overall code quality and then possible vulnerabilities and adherence to secure coding standards. And we also have a static code analysis tool also that automatically examines the source code without running it. It looks for trends that might point to coding errors or security flaws. Through the early use of this technique, development team may identify and address security risks before they become a serious one. Moving on, we also have third-party dependency management. Third-party dependency, which include libraries, framework, and different APIs and different cloud platform in which an application or a system is deployed. Evaluating these third-party providers' security protocols, their performance history, adherence to industry standard, and all part of comprehensive risk assessment process, which would help reduce the risk that might arise from dependency on other parties. And this will empower organizations to make a well-informed decision before incorporating external components. The proliferation of open source components, just like we saw in our previous diagram, though it is cost effective and innovative, it can also introduce peculiar security challenges, including the potential for malicious actors to exploit common libraries and discovery of vulnerability. Likewise, a proactive approach to third-party dependency management allow companies to leverage on the resources and experiences of third-party vendors for components like their APIs, framework, libraries, which accelerates time to market and even reduce the burden on in-house development team. Additionally, by depending on established third-party solutions, businesses can tap into the robust security measure implemented by these vendors, like security audits, patch and regular updates. Moving on, we have the identity access management. In order to enhance security within identity and access management system, it is imperative and mandatory for organizations to implement multi-factor authentication. And it is starting at this stage and with the increasing activities of the cyber criminals, some of the organizations have still not made them MFA multi-factor authentication compulsory in their identity access management. Traditionally, users access system using a combination of password or pins and a unique identifier. However, this method often falls short in protecting against sophisticated cyber threats, which is evident in the colonial pipeline attack that we analyzed earlier on. In that colonial pipeline attack, though the password that was leaked was a strong password, but because the the organization did not implement MFA, there was no additional layer to protect to verify that okay, this to verify and authenticate the user identity. This additional layer of security, the MFA, significantly reduced the risk of unauthorized access, even in scenarios where users' credential must have been compromised. Also, we have the RBAC, which is a role-based access control. This is an advanced access control technique, and the role in the RBAC denotes the level of network access that the worker have. Restricting access permission according to work detail using RBAC help reduce the possibility of unauthorized access. And this approach improves security by guaranteeing that people only have permission required for their responsibility in the development and the deployment process. RBC, RBAC gives both fine-grained and wide control over end users' capability. Users can be classified as an administrator, specialist, or end user, and role and access rights can be matched appropriately. Conclusion and recommendation. And due to challenges encompassing the complexity of supply chain, limited visibility into software origin, and diverse standards. This means that effective strategy, including secure development practice, third-party dependency management, software compliance, zero trust implementation, and stringent identity access management should be implemented by organizations. And also adherence to regulatory guidelines and updates is also crucial for enhancing the security postures of organizations. Regulatory bodies actually plays a pivotal role in reminding organizations of their responsibility to secure customer data and maintain privacy of their data. And sometimes an organization might be tempted to compromise security for increased profit or for in order to like expedite delivery of their project or application. But organizations to try to avoid this kind of temptation and make security part of the ideation from the ideation stage to the deployment of the application. Security should never be treated as an afterthought. In the United States, for example, we have the CISA, which is the Cybersecurity and Infrastructure Security Agency. They've issued a guideline related to security, secure by design, and they've also issued a guideline on software bills of material. So private organizations should ensure that their development team are well versed in these guidelines and they should implement them across board to foster a safer operational environment. By integrating this regulatory standard, organizations are not only complying with legal requirements, but also significantly bolstering their defense against cyber attack, thereby protecting their reputation and ensuring the trust of their customers. Thank you so much for listening to my presentation.